Hello, welcome back to my YouTube channel. And today we're going to be dealing with non-ideal op amplifiers. And this is a classic example of a question that you'd see in exam for an non-ideal op amp. So, just like the normal op amp, we start by solving this question using KCL. So let's do KCL on the X node, as you can see here. So KCL, which is summation of input currents, is the same as the summation of output currents. It'll make it to be I1 to be equal to I2. So if we write it in terms of KVL, I1 is going to be Vs minus Vi all over R1 to be equal to Vi minus V0 all over R2. So for non-ideal op amps, we know that I plus is not equal to I minus, so therefore V plus is not equal to V minus. So this is the prime condition that does occur in an ideal amplifier, in an ideal op amps. So let's simplify this. So if we simplify this, it's going to be R2 into Vs minus Vi is equals to R1 into Vi minus V0. So if we expand this, let's write down here, it's going to be R2 Vs minus R2 Vi is equal to R1 Vi minus R1 V0. So we know that gain, or AV, can also be written as output voltage over input voltage. So if you are to multiply both sides by Vi, or input voltage, we're going to get output voltage is equals to gain times input voltage. And if we are to make an identity for input voltage, we divide both sides by gain, so that you can get input voltage to be equal to output voltage all over voltage gain. That. So you don't actually have to do for input voltage. I just do it for this particular question because it makes it easier for me. So we are going to replace this identity here where you can see where input voltage is. So by doing that, we're going to make this question to be R2 Vs minus R2 into VO over AV is equals to R1 into VO over AV minus R1 V0. So now that we're done with this step, let's take everything with VO to be on one side of the equation. So we take this to the other side of the equal sign. So it will change the question to be R2 Vs into R1 V0 all over AV minus R1 V0 plus R2 V0 all over AV. So let's simplify this question. Let's simplify this a little bit more by taking VO out. So this part is going to just be let's call this one Vs R2. This is a proper way of writing it, and this is going to be V0 into R1 by AV minus R1 plus R2 by AV. So we know that gain is output voltage over input voltage, or voltage source divided by is voltage drain divided by voltage source. So for us to get that question or that equation, let us start by making it to be VO over Vs. So you divide both sides by this entire term, which is R1 over AV minus R1 plus R2 over AV. So you divide both sides by the same term, and by doing that, what you're going to get is we're going to get the equation Vs R2 divided by R1 over AV minus R1 plus R2 over AV is equals to V naught. So you divide both sides by Vs, and if we were to write this in a proper way, it will be VO over Vs is equals to R2 all over R1 AV minus R1 plus R2 AV. So by getting this far, we've already solved the question right here, which is VO over Vs. Now, for us to get this, we need to replace AV by its one pole role of gain, which is GB, or gain bandwidth, over S plus omega A, which is just the 3 dB ripple. So now that we've already gotten this far, let's first simplify this equation to make it easier for ourselves. So let's find a common denominator for the bottom terms. So this is going to be R2 all over, let's call the bottom denominator AV to be common for both. So this is just going to be R1 plus R2. Now this has a denominator of 1, and we are going to make this to be an LCM of AV. So 1 goes to AV times. So this is going to be minus AV R1. And because this is a bottom term, dividing it by AV is like multiplying it with the reciprocal. So we can actually remove that term by multiplying both sides by AV. So sorry, this is V over Vs. And by doing that, we do get the term R2 AV all divided by R1 plus R2 minus AV R1, and then this is obviously VO by Vs. So from the question above, we saw that the value of AV, or which is in its one pole role of state, is GB plus S plus omega A. So if we substitute this into the equation right there, let me just do it here, VO by Vs, what you're going to get is R2 into GB over S plus omega A all divided by R1 plus R2 minus GB over S plus omega A all into R1. So we're going to continue this question on this part right here. So let me just rewrite that very quickly. E over Vs equals to R2 into GB over S plus omega A, R1 plus R2 minus R1 into GB S plus omega A. So here we are again. So if you multiply both sides by S plus omega A at the very top and the very bottom, what we're going to get is this is going to cancel out with that. So we're going to get GB R2 all over, this is R1 into S plus omega A plus R2 into S plus omega A minus R1 GB. So continuing on this particular question, let us solve this question some more. So first of all, let's expand the bottom part. So this is going to be GB divided by R1S plus R1 omega A plus R2S plus R2 omega A minus R1 GB. So let's collect the like terms on the bottom part. So this is going to be GB divided by R1s plus R2s plus R1 omega A plus R2 omega A minus R1 GB. I feel like I've forgotten something. Oh yeah, R2 at the top. Sorry about that. R2 and R2. So let's collect the like terms together. So GB R2 all divided by S R1 R2 plus omega A R1 R2 minus R1 GB. So let's multiply both terms. The top and bottom by 1 over R2 by R1. So on the top part, this is going to cancel out with that, and this is going to go at the top, and that's going to make it R1 GB. Now the bottom part, this is like multiplying with the reciprocal. So the R2 is going to be on the bottom, R1 is going to be at the top, and if you're multiplying across, it's going to be S into R2 plus R2 squared by R1 plus omega A into R2 plus R2 squared by R1 minus R2 GB. And if we were to take out the common terms, R1 at the top would make this one GB, and R2 at the bottom would make this one S into 1 plus R2 by R1 plus omega A into 1 plus R2 by R1 minus GB. Okay, so let's separate this term completely. So this is just going to be R1 by R2 on its own, and this is going to be GB all over S plus or S into 1 plus R2 by R1 plus omega A into 1 plus R2 by R1 minus GB. So if we divide this entire side of the term by 1 over R2 by R1 on all top and bottom, we're going to get R1 R2 all on its own over GB all over 1 plus R2 by R1 divided by S plus omega A minus GB all over 1 plus R2 by R1. And there we go. That is the answer to the question that is right here. But the thing is, this is an inverting amplifier, because the voltage that is going into the negative part of the operation amplifier. So the negative sign at the front here does show that the gain is that of an inverting amplifier. So by doing that, if we just add a minus sign right here, then this question is complete. Thank you. I hope you learned something about non-inverting amplifiers and how to solve this kind of questions. If you have any comments, or if you have any suggestions or anything that you need me to do, and just put it in the comments below and I'll get back to you. Thank you.